Let's take a look at some examples where we're actually using Venn diagrams to illustrate some probabilities. In this example, I've got a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both of the subjects. Display this information on a Venn diagram and hence determine the probability that a randomly selected class member studies all of these things. So let's start off by drawing ourselves a Venn diagram. So I'm going to begin with my sample space. That's the entire class, and there should be 30 people in that class. And I've got one circle here, and I've got one circle here. That's pretty good. And let's start to label stuff. So this first circle, I'll say that the entire sample space is the class. The first circle, let's say that is the physics student, so that'll be P. And then let's say the next circle is C for chemistry. Now, before we fill this in, let me show you what we should not do. And this is a common mistake that some students perform, where we're just taking the numbers and just putting them into the Venn diagram, just kind of shoving them in. And so what I might say is, okay, there's 30 students, so I might put 30 in the sample space, 19 study physics, so here's 19, 17 study chemistry, there are 17, and 15 study both of these subjects. The problem with this is that what I've done is the 19 physics students does actually include the 15 that study both. So what I've done is I've kind of like double counted a lot of these students. So this is not okay. I can't just throw in the numbers in these spaces. I have to do a little bit of figuring out what goes where. So let's tackle that in a more methodical approach. So actually, let's put in all these numbers before I jump into A, B, and C and all that stuff. So what I'll do is let me just kind of put in, let's say that these are unknowns. Some A number of students in here, B number of students in the intersection, some C number of students here, and then of course there's just D students who might not take either of these subjects. What do I know about A plus B? I know that the sum of A plus B, whatever number is in this region and whatever number is in this region, is the total number of physics students, so that's 19. I also know that this number B plus this number C is equal to the number of chemistry students, so that's 17. I also know that B must equal 15, since that is the both subjects. And so from there, I can get all kinds of information. Oh, actually, well, there's one more equation I should say. A plus B plus C plus D, that is the entire sample size. So that's the entire 30. So A plus B plus C plus D, that's equal to 30. So now I can just figure out what these values are. If B must be 15, that means that C must equal whatever 15 plus C is to get 17, so C is 2. A is whatever plus 15 is 19, so A must equal 4. And then D, that would be 4 plus B, which is 15, so 4 plus 15, that's 19, plus 2 is 21. So that means that D must equal 9. Okay, so maybe what I'll do now is I'll actually write in those numbers. So I've got 4, let's go with another color here. Let's go purple. So there's 4 who take only physics, there are 15 who take both, there are 2 who take just chemistry, and there are 9 who don't take any of those classes. All right, so now we're ready to jump into what's next. And actually, you know what I'll do is let me duplicate this and duplicate page, clone page. And then what I'll do is I'm just going to kind of get rid of this over here, and let's pick up where we left off. Or let's pick up on solving some of these other problems here. So now I want to find the probability that I study both subjects. So the probability that I study both, that's going to be given as the number both. So I want the number of elements in the intersection of P and C divided by the number of students total. So the number of, I'll say, class. All right, and that's going to equal 15, which is the intersection of P and C, divided by 30, which is equal to 1/2. So half the students take both. And so the probability of selecting one random is 1 out of 2. For B, the probability of selecting at least one of someone, grabbing someone who takes at least one of these subjects, that's going to be the union of these two sets. So the probability of studying at least one is the probability of P and the union C. And that's going to be really everything in these circles. And that's going to be given as the sum of all these numbers. So that's 4 plus 15 plus 2 over the sample size, which is 30, which is equal to, that's 19, that's 21 over 30. So that's going to equal 7/10. Moving right along, maybe I'll duplicate this one more time. Let's get rid of all this. For C, I want the probability that we study physics and not chemistry. And we could express that as the probability of P and not C. So that's what I'm looking for here. So I'm looking for the region that is physics. So physics is this entire region, but I do not want to include chemistry students. And so this intersection, it would include the chemistry students. So this is going to be given then as this region here. That's going to equal 4 over the total sample size, which is 30. So that's going to equal 2/15. D, the probability that one of these students studies exactly one of the subjects. So what that's going to be actually everything in that is, or it's going to be wherever there is not an intersection, but I'm still in a circle. So that's going to be the probability of exactly 1 is going to be given as 4 plus 2 over my sample size, which is 30. So it's going to be 6 over 30, which is equal to 1/5. And then 2 more here. So, or no, last one actually. So E, the probability that they study neither subject. And the probability that you study neither subject is just going to be the students that exist outside of the events of taking physics and chemistry. So this is, you could also write this as the probability of not P or C. And that's going to be given as 9, the people who aren't taking either, over 30, the entire sample size. So let's see, that reduces down to 3/10. All right, so quite a bit of work to figure that one out. But once you find what that Venn diagram looks like, you're basically just pulling numbers off of this. Just make sure you're pulling them from the right space. So why don't you try an example kind of like this, where I give you a Venn diagram, pause the video, read this one out, and see if you can figure it out. And here is the solution to this problem. Take a look at it, make sure you got it all figured out.